Welcome to the deep dive. It's funny how we get drawn to, the really rare and exotic diseases, almost a morbid fascination sometimes.
Right, the things that sound dramatic or unusual.
Exactly. But there's a striking observation in our sources today. While we focus on the rare stuff, maybe the most devastating condition is incredibly common. Major depression, sometimes called the common cold of psychopathology.
That's a really potent phrase, isn't it? And the numbers are staggering. Estimates suggest anywhere from 5 to maybe even 20% of us will face a major, truly incapacitating depression at some point.
Okay, so let's dive into that. Today we're looking at a chapter that really gets into the weeds on the link between stress and, well, something much deeper than just feeling blue, major depression.
Yeah, what it actually is, how it shows up, and importantly, the biology and psychology behind it.
And we need to be clear, this isn't about having a bad day or feeling sad because something specific happened. This is a really crippling disorder. It can just wreck people's lives, their work, their families.
And what's so interesting in this material is how stress is the thread running through absolutely everything. So we'll break down, the core features of major depression, how our brains and bodies react in some surprising ways,
hmm
and look at insights from Freud, actually, and also from experimental psychology. The goal is to understand not just what's happening, but why it matters, and maybe how understanding it helps.
Right. Because we all use that phrase, don't we? Oh, I'm so depressed today. Usually after something pretty minor.
Totally. But the clinical definition, what doctors mean by major depression, it's horrific. It's not just sadness, it's this total loss of joy. It can lead to suicidal thinking, literally not being able to get out of bed.
And that feeling of, not even deserving to feel better.
Exactly. Our source puts it starkly. It's a genetic neurochemical disorder requiring a strong environmental trigger whose characteristic manifestation is an inability to appreciate sunsets.
Wow. Inability to appreciate sunsets, that really hits home. It points straight to that core feature you mentioned, anhedonia.
Anhedonia. Yeah, the inability to feel pleasure.
Just imagine you get that promotion you worked years for, or you get engaged to the love of your life, and you feel nothing.
Or worse, maybe you feel like you don't deserve it. The chapter gives this really personal example from the author, finding pure joy playing soccer, feeling dizzy with gratitude for animal existence.
Yeah.
That feeling, utterly alien to someone deep in depression with anhedonia, it's just gone.
So incredibly sad. And alongside that emptiness, there's often this immense grief and guilt.
Overwhelmingly so.
Yeah.
And it becomes incapacitating. Sometimes it even twists into delusional thinking.
Delusional. Like how so? Can you give an example?
Yeah, the book describes this middle-aged guy who's recovered from a heart attack, but he falls into a major depression. Physically, he's getting better. The nurses track his progress, right?
Okay.
They tell him, hey, you did 2 laps around the corridor today. Yesterday, just 1.
Yeah.
But he's convinced he's getting worse. He insists the hospital must have secretly, overnight, renovated the building to make a smaller corridor just to trick him.
Whoa. So his depression is literally changing his perception of reality.
Exactly. His emotional state is completely warping how he interprets the everyday world. It's not just a bad mood.
Which fits with what Aaron Beck from the University of Pennsylvania talks about, that depression is fundamentally a disorder of thought, not just emotion. Everything's seen through this negative filter.
Absolutely. There are studies showing this. You show depressed individuals 2 pictures side by side. One's a happy family dinner. The other is the same people around a coffin. Later, they're much more likely to remember the funeral scene.
The glass is always half empty, or maybe completely empty.
Or maybe shattered on the floor, yeah.
Another thing mentioned is psychomotor retardation. Can you explain that?
It's basically a slowing down of movement and speech. For many depressives, everything feels like wading through mud. Even making a simple phone call, like arranging a doctor's appointment, feels utterly exhausting.
Just overwhelming effort.
Right. Though, interestingly, some people experience the opposite. Psychomotor agitation, kind of restless, anxious energy. And, well, it makes sense that if you have anhedonia, a loss of interest in sex is pretty common too.
Okay, and then there are the vegetative symptoms. What does that term mean?
These are the more kind of baseline physical changes.
Yeah.
And they're often the opposite of what we might expect from just feeling sad.
Opposite how?
Well, think about it. When most of us feel down, maybe after a breakup or a bad day, we might, curl up and sleep more or eat more comfort food.
Yeah, definitely. Ice cream comes to mind.
Right. But with major depression, it's typically the reverse. Significant weight loss is common, and so is sleep loss.
Sleep loss. That seems counterintuitive if someone feels exhausted.
It does, but it's a hallmark. Not just trouble falling asleep, but specifically early morning awakening. Waking up at, say, 3:30 a.m. day after day for months and not being able to get back to sleep. The whole structure, the very architecture of sleep gets messed up.
Wow. Okay. And here's something that sounds like a paradox. They seem to have no energy, they're slowed down yet. They often have high levels of stress hormones.
Exactly. High glucocorticoids.
Mm-hmm.
The source uses this great image. They're like a tightly coiled spool of wire. On the outside, they might seem lethargic, but inside, they're fighting this enormous, draining internal battle.
So it's not laziness, it's intense internal effort that's just exhausting them.
Precisely. And all these variations start to hint that depression isn't just one single thing. There seem to be different types, which suggest different biological factors at play.
Right, like unipolar versus bipolar depression.
Exactly. Unipolar is when you fluctuate between periods of deep depression and feeling, well, normal or baseline.
Okay.
Bipolar disorder, which used to be called manic depression, involves swings between that deep depression and episodes of mania.
And mania isn't just being really happy or energetic, is it?
Oh, not at all. It's way beyond that. It's a state of wild, disorganized hyperactivity. The book mentions a case, a woman with bipolar disorder, unmedicated, on welfare. In a manic state, she bought 3 Cadillacs from loan sharks in 1 week.
3 Cadillacs.
Yeah, and she didn't even know how to drive.
Hmm.
People experiencing mania can go days with almost no sleep, talk nonstop, jump from idea to idea, and do incredibly risky, foolhardy things like trying to prove they're immortal or giving away their life savings. It's chaotic and often devastating.
That sounds terrifying, and sometimes these cycles have a rhythm.
Yeah, like malaria has a fever rhythm. Some people with bipolar might have, say, 5 days of mania, then a week of depression, then back again, repeating for years, regardless of what's happening in their lives.
Which points strongly towards biology. And then there's SAD, seasonal affective disorder.
Right, depression that specifically hits during the winter months. It seems linked to light exposure and the body's internal clock. Again, feels very biological, less tied to immediate life events.
Okay, so we have these symptoms, these different types. Let's get into the brain chemistry. How do our brain cells actually talk to each other? Can you give us a quick picture?
Sure. So imagine you have brain cells, neurons. They send signals. It starts with an electrical impulse traveling down the neuron, like a wire.
Got it.
When it reaches the end, it triggers the release of chemical messengers. These are the neurotransmitters into this tiny gap between neurons called the synapse.
Okay, a chemical handoff.
Exactly. These chemicals float across the synapse and dock onto receptors on the next neuron, like a key fitting into a lock. This excites the next neuron, passing the message along.
And what happens to those chemicals afterwards?
Crucially, they don't just hang around. They're either sucked back up by the first neuron for reuse, that's called reuptake,
Right.
or they're broken down by enzymes. Keeping this whole process in balance is vital for normal brain function.
Makes sense. So the big theory with depression involves which chemicals?
The main ones implicated, historically and currently, are norepinephrine and serotonin. The idea is that depression might involve having too little of one or both.
And what's the evidence for norepinephrine being involved?
Well, early antidepressants, like tricyclics, work by blocking the reuptake of norepinephrine. This keeps more of it active in the synapse for longer.
Okay, boosting the signal.
Right. Another class, MAO inhibitors, block the enzyme that breaks norepinephrine down. Again, the result is more signaling. And conversely, some older drugs used for things like high blood pressure actually depleted norepinephrine.
Uh-oh.
Yeah, and they could sometimes trigger depression in people who weren't depressed before. Strong evidence for its role.
So if low norepinephrine is a problem, how does that connect to the symptoms like anhedonia?
One very appealing idea, the pleasure pathway hypothesis, came from early research. Scientists found specific brain areas, particularly in rats, that, when stimulated electrically, seemed to produce incredible pleasure.
Pleasure so intense the rats preferred it to anything else.
Pretty much, yeah. They'd press levers for hours, ignoring food, water, sex, just to get that stimulation. This pathway exists in humans too, and norepinephrine is involved, although dopamine is now seen as maybe the primary player there. But the idea was a shortage of norepinephrine in this pathway could mean pleasures just aren't registered properly. Hence, anhedonia.
That makes intuitive sense. Is that the only theory?
No, another perspective focused on movement. Since norepinephrine is also involved in regulating motor control, maybe low levels explain the psychomotor retardation, the difficulty in initiating and carrying out actions.
So difficulty feeling pleasure versus difficulty doing things.
Kind of, yeah. Though, honestly, the research hasn't definitively proven one over the other, and it's likely more complicated than either simple explanation.
And there's that timing issue you mentioned earlier. Antidepressants change the chemistry fast, but people don't feel better for weeks.
Exactly. That lag time forced researchers to rethink things. It couldn't just be about more is better. This led to some revisionist theories.
Okay, like what?
Well, one idea flipped it. Maybe the initial problem is actually too much norepinephrine signaling, or maybe receptors that are too sensitive. Antidepressants first make it even higher, causing the receiving neuron to protect itself by reducing the number of its receptors called downregulation. Eventually, this downregulation overcompensates, leading to less overall signaling, and that's when symptoms improve.
Huh. So the immediate effect isn't the therapeutic one.
Potentially not. Another sophisticated idea involves autoreceptors. These are like feedback sensors on the neuron that sends the signal. They monitor how much neurotransmitter is in the synapse.
Okay.
The theory goes. Antidepressants might cause these autoreceptors to downregulate more strongly than the regular receptors on the receiving cell. This makes the sending neuron think it's releasing less than it is, so it ramps up production and release. Net effect. More norepinephrine signaling in the long run. This might also explain how things like ECT, electroconvulsive therapy, work.
Fascinatingly complex. It's like the brain is constantly fine-tuning itself.
It really is. And while norepinephrine was a major focus early on, the game changed again with drugs like Prozac.
The SSRIs, right? Selective serotonin reuptake inhibitors.
Exactly. These target serotonin specifically, and they are very effective for many people. This strongly suggested serotonin is also deeply involved.
So it's likely both.
That's the consensus now, yeah.
Yeah.
Most researchers believe depression involves issues with both norepinephrine and serotonin systems. Maybe the amounts released, maybe the receptors, maybe the intricate regulation between them. It's probably a symphony or maybe a cacophony involving multiple players.
Okay, beyond the chemicals, what about larger brain structures or hormones? You mentioned the cortex whispering sad things.
Right. If you think of the brain simplistically in layers, the basic survival stuff at the bottom, the emotional limbic system in the middle, and the thinking cortex on top, our human specialty is that cortex. It generates abstract thoughts, worries, existential dread.
Stuff that animals maybe don't experience in the same way.
Probably not. And in depression, it seems like the cortex takes these abstract negative thoughts, I'm worthless, life is meaningless, and communicates them down to the more primitive emotional parts of the brain.
So an abstract thought triggers a primal physical stress response.
Essentially, yes, it makes psychological pain feel as real and threatening as, say, being chased by a predator. This might explain why procedures like cingulotomy, which sever some connections between the cortex and deeper structures, can sometimes alleviate severe, untreatable depression, though it's a drastic measure and can blunt positive abstract experiences too.
A heavy trade-off. What about hormones? We touched on stress hormones being high.
Right, the elevated glucocorticoids fit the picture of chronic stress. But other hormones matter too. For instance, having too little thyroid hormone can directly cause symptoms identical to major depression.
So what looks like a psychiatric issue could actually be endocrine.
Absolutely. Always important to rule out. And melatonin imbalances seem linked to seasonal affective disorder, which is why light therapy, affecting melatonin, can help some people.
Let's circle back to something you mentioned earlier, the sex difference in depression. Women experience unipolar depression much more often than men. Why?
It's a huge question, and the answers aren't simple. There are cognitive theories suggesting women might tend to ruminate more on problems, which increases risk, while men might distract themselves or act out.
Okay, rumination versus distraction.
Then there are psychosocial theories. In many societies, women historically had less control over their lives, less agency. Since depression is often linked to feelings of helplessness or lack of control, this could increase vulnerability.
Plausible theories, but do they explain everything?
Not quite. They don't fully explain why the rates for bipolar disorder are roughly equal between men and women. And crucially, they don't easily explain why women's risk for depression spikes at very specific reproductive times around menstruation, menopause, and especially right after childbirth.
The hormonal connection again.
It seems highly likely. Estrogen and progesterone levels fluctuate massively during these times. Progesterone can drop 1,000-fold after birth. These hormones don't just affect reproduction. They interact with and regulate neurotransmitter systems in the brain. These huge shifts could be potent triggers for depression in vulnerable individuals.
That also ties into something you said about drug side effects.
Yes. Women often report more side effects from standard antidepressant doses. It's not necessarily that they're more sensitive. Estrogen actually influences how quickly drugs are broken down by the liver. Higher estrogen can mean slower breakdown, leading to higher effective doses.
So the standard dose, often based on male physiology.
Exactly. Historically, a lot of drug testing was done primarily on males. This meant dosage recommendations weren't always accurate for women or for different age groups or ethnicities for that matter. It really underscores how vital it is to consider these factors in treatment.
Okay, we've covered a lot of the biology, neurotransmitters, brain areas, hormones, but what about the psychology, the inner experience? You mentioned Freud earlier.
Yeah, and while it might seem old-fashioned to some, Freud's essay Mourning and Melancholia offers some really profound psychological insights, even if they're hard to test scientifically.
What was his core idea there?
He was puzzling over why some people grieve a loss and eventually recover, mourning, while others collapse into this state of complete self-hatred and despair, melancholia, or what we'd call major depression.
Okay, mourning versus melancholia.
He suggested both involve losing something or someone deeply loved a love object. But he argued, every important relationship contains ambivalence, mixed feelings. Love, yes, but also, inevitably, some frustration, anger, maybe even hatred.
That sounds realistic.
It does. In normal mourning, you work through the loss. But in melancholia, Freud thought, the person becomes obsessed with the ambivalence they felt toward the lost person or goal. They can't let go of the intense love and the intense hatred felt simultaneously. It creates this unbearable internal conflict.
So the grief gets tangled up with self-attack.
Precisely. He thought this explained the intense grief you're grieving, not just the loss, but the lost chance to ever resolve those conflicting feelings, and the intense guilt, maybe stemming from a hidden, terrifying flicker of relief or even pleasure at the loss, which makes the person feel like a monster.
Wow, that's dark.
Deeply. He even suggested the depressed person might unconsciously take on irritating traits of the person they lost, as a way to sort of continue the argument internally, a form of self-punishment. His school summed it up as aggression turned inward.
And that internal battle explains the symptoms.
That was the idea. The anhedonia, the psychomotor retardation, the exhaustion, the suicidal thoughts, all seen as the psychic energy drained from this constant internal war. Powerful ideas, but as you said, tricky to fit into modern biological frameworks.
So where does experimental psychology come in? You mentioned learned helplessness.
Yes. This model, developed mainly by Martin Seligman and Stephen Mayer, provides a really compelling bridge between psychological stress and the biology of depression. It's incredibly informative.
How's it work? What's the experiment?
The classic setup involves animals, often rats. Imagine exposing them to something unpleasant, like mild electric shocks or loud noises. But crucially, the stressor is uncontrollable and unpredictable. They can't escape it. They can't anticipate when it will happen.
Okay, inescapable, unpredictable stress.
Right. After repeated exposure to this, something profound changes. If you then put these same rats in a new situation where they can actually learn to avoid the stress, say, by moving to a different part of the cage, they often don't even try.
They just give up.
They just give up. They passively accept the stress. They've learned to be helpless. And follow-up studies using yoked controls showed it wasn't the physical stress itself, but the psychological stress of lacking control and predictability that caused this.
Lack of control's the key. And how does this relate to human depression?
The parallels are stunning. First, there's a motivational problem. Like depressed humans often feel, these animals act as if it's pointless to try. I'm too tired. It won't work anyway.
That sense of futility.
Exactly. Second, there's a cognitive problem. They seem to stop paying attention to information that could help them gain control. Even if a solution is presented, they don't perceive it or learn from it. It's like the depressed person who only sees the negative, who overgeneralizes from one bad experience to assume everything will be bad.
Seeing the coffin, not the dinner table.
Precisely. And remarkably, learned helplessness in animals also produces many other symptoms of depression. Anhedonia, they lose interest in grooming, sex, food, psychomotor retardation, sometimes even self-injurious behavior, and the vegetative symptoms like sleep disruption and elevated stress hormones.
And the neurochemistry.
Critically, these animals also show depletion of norepinephrine in certain brain areas. And guess what helps them recover? Antidepressant drugs and even ECT. It's an incredibly powerful model.
Can this happen in humans too? Learned helplessness?
Oh, yes. And surprisingly easily, at least transiently. Studies subjected human volunteers to, say, uncontrollable loud noises. Afterwards, these people were worse at solving simple puzzles or learning new tasks compared to controls who experienced escapable noise or no noise. Even playing an unwinnable card game could induce temporary helplessness in subsequent social situations.
So, experiencing uncontrollability can temporarily impair our ability to cope later.
It seems so. And there's individual variation. People who tend to have an external locus of control, believing outcomes are due to luck or external forces, seem more vulnerable to learned helplessness than those with an internal locus of control, people who believe they generally shape their own destiny.
That makes sense if you already feel like things are out of your hands.
Then experiencing actual uncontrollability just confirms that belief and makes it harder to bounce back. This really helps us understand how early life experiences, maybe a string of failures, a hypercritical environment, loss, could teach someone lessons in helplessness that distort their beliefs and increase their risk for depression later on.
As Silliman said, it's not just general pessimism, but pessimism specifically about what you can achieve through your own actions.
Exactly. It's pessimism about efficacy.
So we have the biology, the psychology.
Yeah.
How does this all come together? How does stress actually trigger depression in some people but not others?
Okay, this is where the model gets really interesting. It integrates things. We know stress directly impacts brain chemistry, right? One key effect is that stress depletes norepinephrine, particularly in the limbic system, the emotional brain.
Right, the stress uses it up.
But here's the crucial bit. Stress also normally triggers the synthesis of more norepinephrine. There's an enzyme, tyrosine hydroxylase, that ramps up production. For most of us, this built-in recovery system kicks in. We might feel stressed or blue for a bit, but the brain compensates, replenishes the supply, and we recover.
Okay, so there's a natural bounce back mechanism.
Exactly. So the hypothesis is, what if people vulnerable to depression have a subtle defect in this recovery mechanism? What if, after stress depletes their norepinephrine, their brain doesn't ramp up the synthesis enzyme effectively?
Ah, so they don't bounce back chemically?
Precisely. Without stress, they might function perfectly normally. Their baseline norepinephrine levels are fine. But when they encounter a significant stressor, something that might be tough but manageable for someone else, their norepinephrine levels drop and stay dropped or drop further because the compensatory synthesis doesn't kick in properly.
So the stressor has a much bigger, longer-lasting impact on their brain chemistry. It's like a small leak becomes a flood because the pump is broken.
That's a great analogy. It's a neurochemical vulnerability exposed by stress. It mirrors that cognitive overgeneralization. One stressful event leads to a cascading chemical deficit.
And this model brings together the biology and the environment.
Beautifully, I think. It suggests depression isn't just an inevitable biological destiny, nor is it purely psychological. It's often about a biological propensity that gets revealed or triggered by environmental stressors, particularly those involving lack of control or predictability.
It really highlights that interplay.
It does. And while it's still a developing model, it offers a framework for thinking about how biochemical vulnerabilities interact with life experiences. And importantly, it suggests potential points for intervention, helping people manage stressors, build coping skills, or perhaps finding ways to bolster that neurochemical resilience.
So wrapping this up, what are the key takeaways for you, our listeners? We've journeyed through major depression, seeing it not just as sadness, but as a complex, often devastating illness marked by things like anhedonia, cognitive distortions, physical changes, sometimes even biological rhythms.
Yeah, we explored the brain chemistry, the roles of norepinephrine and serotonin, the complexities of their regulation. We touched on hormones, brain structures, and those intriguing sex differences.
And we looked at psychological perspectives, from Freud's idea of aggression turned inward to the really powerful experimental model of learned helplessness, linking that feeling of uncontrollability directly to depressive symptoms and brain changes.
And crucially, how stress acts as a potential trigger, interacting with underlying biological vulnerabilities, possibly related to how effectively our brains replenish key neurotransmitters after being depleted.
It paints a picture of an illness that's both profoundly biological and deeply shaped by our experiences in psychology.
Absolutely. And maybe a final thought to leave you with. This deep dive really underscores that the battle against depression is often fought entirely internally. It's this silent, exhausting struggle. If psychological stress can literally deplete the chemicals that allow us to feel joy and motivation, and if our biological capacity to recover from that depletion varies, well, then understanding these processes isn't just about disease, it's about understanding resilience, vulnerability, and the very real limits of just telling someone to cheer up.
A powerful point. Understanding the mechanism helps foster empathy and points toward more effective support. Thank you so much for joining us on this deep dive.
We hope exploring this chapter has given you a clearer, perhaps more compassionate understanding of the complex relationship between stress and depression.